Okay, so trying number 6A, page 39. For this one, we'll need equation 3. I just tried using the graphs to solve it, and I'm simply unable. There's got to be a trick that I'm just not aware of for this one. So you need the equation 3. Equation 3 reads like this. Delta D delta, sorry, is V1 VI delta T acceleration average delta T 2. So on question 6, starts at rest. The spacecraft starts at rest. So it's on the ground, right? Spacecraft, and then it goes up. So it starts at time 0, and it starts with a displacement of 0, right? Now, this part, our initial velocity, it's at 0, sorry, because the spacecraft has not started moving yet at time 0. And so this component here is going to get cancelled. It's just gone because the VI is 0. So we're just left with this. So the displacement, and we know the displacement. So before I start solving, plugging in our value, we should just isolate the acceleration here. So I'm left with 2. We'll go multiply here, and then divide by delta T squared. So I'm left with 2 delta D, right? Just the 2 of here, and then divide, because it goes under. Divide delta T squared, and then I'm left with acceleration average. Okay, well, it's pretty simple. So the displacement is, so let's start plugging in. It's 4.50 times, sorry, that's meters. I'm not going to write the up because it really makes no difference for us. We know it's going up. And divide by delta T. Get straighter. Delta T is 4 seconds, and it's squared. So it's going to be 16. That's going to give me my acceleration. So this is going to be over 8. So if I calculate that, so what is that? So it's 4 times 100 divided by 8. So 56. So the book was right. Acceleration 56. Now I have 3 significant digits, and my delta T is 4.0. So that's 2 significant digits. I have to round, so it's 56. second square. Yeah. That one is pretty simple when you use the equation. I didn't post my work earlier trying to solve it graphically. I was like 20 minutes on this. 1.5, so 56 meters square per second square, sorry. It is up, so we are right on. Okay, so that was straightforward. At what velocity is the spacecraft traveling when it reaches the altitude? So this is V final. So V final. Well, for this one, I can do it geometrically using the graph. So I'll show you because I'll show you using that way. But what about I show it using the equations actually? It's not lost. You guys, some of you might prefer to do it using the equations. I'm fine with that. What are we looking at? We are looking at V final so I'm looking at 37. We have the initial, we have the delta time. So equation 2 looks like it would work really well. Yeah, it's actually really simple. So equation 2 should work. So equation 2 reads rather. So velocity final equals initial velocity. Now this is 0, right? So we're going to scratch it right away. Plus acceleration average times delta t. Okay, I like this one. That's easy. If we plug in, we get, we have the accelerations, 56 meters per second square. My delta t was 4 seconds, right? 4.0. Yeah. So just times 4.0. Okay, so that's really simple. We like them like that. 56 times 4 is 224. The second, the square cancels the second. So 224 meters per second. Is that the book's answer? Right. Again, we have to be careful with our significant digits. So 2 significant digits, 2 significant digits. So I have to round after the 2 here. And if I round, I get 220 meters per second, or 2.2 times 10 power 2 meters per second. And this is up. So don't forget the direction. Okay, so that was page 39, number 6.